Okay, so in this video today we're going to be looking at finding inverses in modular arithmetic. So how about we start with a review first of mod real quick. And so we have an example, 24 mod 11 equals 2, which can also be written as 24 is equivalent to 2 mod 11. You can see that broken down. Looks like 24 equals 11 times 2, which is 22, plus 2. So it's a multiple of 11 with a remainder, which is equivalent to what it's equal to in mod. So another example we have is going to be, what's an example of 1 mod 6? Something that's equivalent to that. So we look into that. 7 is equivalent to 1 mod 6 because if we break it down, we see that 7 is equal to 6 times 1 plus 1. So we have a remainder of 1, as you can see there. So let's look at some examples of inverses in modulo. So looking at 9 times what is equivalent to 1 mod 26. So you're looking at a multiple of 26 plus 1 is equal to a multiple of that number you have on the left side. So you see that 9 times 3 is equal to 27, which is equivalent to 26 times 1 plus 1. And therefore 9's inverse in mod 26 is going to be 3. Then we can look at mod 11. So 9 times blank is equivalent to 1 mod 11, and we see that we times 11 times 4 is 44, plus 1 equals 45. We see it broken down. 9 times 5 is actually going to be equivalent to that number there, so we have 44 plus 1 equals 45, and therefore 9's inverse is 5. That can also be expressed as 5's inverse is also 9. They're reciprocal in that way. So we express it like this, so 5 times 9 is equivalent to 1 mod 11 as well, so 5's inverse is the same. So 5's inverse is 9, and 9's inverse is 5. Another way to find inverses is through the greatest common divisor. So we express this as GCD 20 and 88. So what's the greatest common divisor between 20 and 88? In the example, we find that it's 4. So you break it down, doing 88 equals 20 times blank plus blank. So we have 20 times 4 plus 8 is going to equal to 88. And then we swing it down. We see 20 equals 8 times 2 plus 4, and then 8 equals 4 times 2 plus 0. So greatest common divisors, remember we're breaking it down to find that remainder before we get 0 as our final remainder there. So that's just a quick review of that. But a way to find inverses through this is, we have another example here, greatest common divisor between 42 and 95 is equal to 1, as we see we break it down here, getting down to that last one, and you can have another line there at the very bottom saying that 2 is equal to 1 times 2 plus 0, and that would be your final line, but you're really just looking for that 1 above 0, so the very last thing you break it down to is that plus 1, so their greatest common divisor is 1. So then we see we can find the inverse of 42 in this by breaking it down in a different way. So 42 times what is equivalent to 1 mod 95, since they have that remainder of 1, their greatest common divisor is 1, so we know that that lower number, that first number we have there, is going to have an inverse in mod 95, or mod of the bigger number. So we break it down. We see this again here. By looking at broken down, finding that remainder. So we have 95 equals 42 times 2 plus 11, 42 equals this, 11 equals that, 9 equals that. So you're going to look at that, and we're going to work up this list in a backwards fashion. So let me show you. We have 11 equals 95 minus 42 times 2, 9 equals 42 minus 11 times 3. So we just switched it around to set it equal to those remainders that we have. So that 1 equals 9 times 2, 9 minus 2 times 4. So 1 equals 9 minus 2 times 4. We're going to use this to find the inverse of 42 in mod 95. So we break it down. We have 1 equals 9 minus 2 times 4. And feel free to go back and reference that list or write it down as you're working your way up. And we're going to see that 2, we take that 2 and we replace it with what we found 2 to be equal to in our set of remainders. We have 9 minus 4 times 11 minus 9 times 1. We just replace that with what 2 is equal to in our set of remainders that we rearranged there before. And then we break it down even more. We see that 4 times 9, we have 4 9s there, plus that 9 we have on the very outside. So total they come to 5 times 9. minus 4 times 11. We go another step here. We're replacing that 9 next, because we have that remainder of 9 when working up our list. And so we do 5 times 42 minus 11 times 3 minus 4 times 11, and we see that we have that common factor of 11. So you swing that out, do 15 11s, put the combined like terms there. We have 5 times 42 minus 19 times 11. And moving on, just clearing up some space to start at the top again. 5 times 42 minus 19 times 11. And then we replace 11, which is our next remainder on our list there. We have 5 times 42 minus 19 times 95 minus 42 times 2. Combining like terms again. And we get down to 1 equals 43 times 42 minus 19 times 95. So in the end, we see that 42 times 43 is what's giving us our 1 in mod 95. So that is another way, instead of multiplying it all out and trying and doing trial and error with a bunch of multiples, you can find an inverse in a mod there. So thanks so much for watching. We see that 43 is equivalent to 40. So we see that 42 times 43 is going to give you that 1 mod 95. So we're using bigger numbers and you find that their greatest common divisor is 1, then we know that that smaller number of the set is going to have an inverse in that mod. So that's one way to find its inverse. So hopefully that helped you guys. Thanks so much for watching. Yeah.